Let's review the formal definition of the limit by looking at a particular website that has a nice little GeoGebra calculation. I'm at webspace.ship.edu. This is Professor Renault at Shippensburg with some GeoGebra materials. And here we have a function that's graphed here in our picture. The function is sine of x times x minus 1 over x minus 1. This has the effect of giving us the sine curve, except it puts a hole at 1. If the function is sine of x times x minus 1 divided by x minus 1, the function is undefined when x is 1 because we have a 0 in the denominator. However, what is the limit as x approaches 1? You would think from this graph that the limit as x approaches 1, down here, this red line along the x-axis, at this dot, x is 1. If I plug in 1, I don't get a value, but if I plug in numbers close to 1, I get something close to about 0.84. And so the question is, if the limit as x approaches 1 is about 0.84, how do we formally describe that? On the y-axis, we have this green bar. This is 0.84 plus or minus epsilon. The empty circle has height about 0.84, or the sine of 1. And if I move over to the y-axis, this green bar takes that value, goes up a little bit, goes down a little bit. On the x-axis, we have the value 1, and we can go to the right a little bit, to the left a little bit. On the x-axis, when we move to the right a little bit or to the left a little bit, what do we call that distance or difference? That's my delta. Now I can shrink delta. I have a bar I can pull up here. In this picture, delta is 0.231. If I shrink delta, so we're closer and closer, notice how my band gets thinner and thinner. Now when delta is smaller, 0.121, we go from 1 up to 1.121, and we go from 1 down to 1 minus 0.121, whatever that is. The red band here is 1 plus or minus delta. That gives some points on the curve, and the points on the curve give this green bar, this green interval, the epsilon band. Again, I can shrink. If I continue to shrink delta, I'm getting closer and closer to values like the 0.84. So again, delta is the interval along the x-axis. Go up delta or down delta. And as we do that, we end up creating an interval along the y-axis. Delta 1 plus or minus delta is in red. 0.841, the sine of 1, plus or minus epsilon is presumably in green here, although that epsilon interval is not balanced around our value. But here is the intuition you need: red going up and down delta, green going up and down epsilon.